Hey everyone, today we're going to try to explain the weak acid with a strong base titration. I looked it up on YouTube and Google, and there are a lot of examples, but all of them contain, none of them contain the diprotic acids or bases. So we're going to do this one that includes a diprotic strong base. So the question is 40 milliliters of acetic acid, which is a weak acid. It's CH3COOH. It's an organic acid with a concentration of 0.15 molars are being titrated with strong base, which is calcium hydroxide that has a concentration of 0.1, and the Ka of the weak acid is given, of course. So let's say it's always better to draw like what's going on. So here we have 40 milliliters of the weak acid, and we're titrating it with strong base. Okay, and it's asking us what is there are four parts to this question. So the first part is what is the pH at the start, like before we add any base at all. So only we have the weak acid. So if we have a weak acid or a weak base and we want to find the pH, we just write the equation in equilibrium. So we have CH3COOH. Because it's a weak acid, it dissociates only partially. So it's going to give its proton, which is this hydrogen, and we're going to be left with the salt. This salt of a weak acid, it's basic. So this is the basic salt and the hydrogen. And we always deal in equilibrium with concentration, not moles. So the concentration is 0.15 at the beginning. And of course, before it dissociates, we have 0 molars of the ions of the salts. So let's say it dissociates like by X. We don't know how much it dissociates, so we put minus X, and at the end we have 0.15 minus X, and here of course we have plus X, and here we have X. And the equation is Ka equals the products, you divide them by the reactants, so x squared divided by 0.15 minus x. Now, because the K is very small, it's 1.8 times 10 to the minus 5, I usually neglect x because it's too small. Some students like to do it. I don't have the power for it. You can do it, but you're gonna it's gonna take you a longer time, but you're gonna get exactly the same answer if the K is small. Small could be like smaller than 10 to the minus 5 or minus 4. Because as you can see, the concentration is 0.15, so it's much larger than the Ka. So X is gonna be very small. You can neglect it if the Ka is small. So we're gonna get Ka times 0.15 equals x squared. And don't forget that X is the concentration of H+. That's what matters to us to find the pH. So if you do the calculations, you're gonna get X equals 0.0 0.016. So this is the concentration of H plus, and to find the pH, so pH equals minus log the concentration of H plus. This is the concentration of H plus. And pH equals minus log of 0.0016. And you're gonna get the pH should be minus log 0.0016. So it's gonna be 2.79. It makes sense because it's a weak acid, so it's acidic. It's below 7 and it's not that strong because it's, let's say it's between 2 and 3. So it makes sense. Okay, so this is the first part. So question number 2. What is the pH after we add 29 milliliters of base? A common mistake would be writing the equation, like the whole equation, balanced with the acid and the base, because in that equation you're going to get at the end the salt, and you don't want the salt. You want, because if you have a weak acid with a strong base in the buffer equation, you want the concentration of the salt alone, like the salt of the acid, which is the acetate in this case. And if you're gonna write the whole equation, including the calcium and the whole base, you're gonna get the salt of calcium acetate. So if you want to do the whole equation, you have to dissociate the calcium acetate. So you're going to get the concentration of acetate, which is going to be double the concentration of the calcium acetate salt. So what you're going to do in this case, if you have a diprotic base, first you're going to do the equation of the base alone, of the strong base or the strong acid alone. Ca plus 2. Of course, aqueous, I'm not going to do all of this. Plus OH minus. So after we add 29 milliliters of base, to find the moles of the base, you're just going to do the concentration times the volume. So it's 0.1 times 29 divided by 1000, because you need the volume in liters. So you're gonna get 0.0029 moles. And what matters is the concentration, the moles of the hydroxide. So it's going to be times 2 because of the coefficients, as you can see in the balanced equation. So you're going to get 0.0058 moles. After you do this, let's put it like on top, the moles of the OH, because that's the only thing we're going to need. OH minus moles. I have a terrible handwriting, I know this. What matters is that we get this. Let's remove this and continue. So after we find the moles of the OH minus, we get back to our acid equation. So you're going to react the acid. This is the important part. You're going to react the acid not with the base. You can react, but as I said, you're going to need to dissociate the salt. So it's just easier to react your acid with the hydroxide only, because you already know the moles of the total hydroxide that you added. And of course, you're gonna get water and the salt that you need for the buffer equation. Like this. See, the OH took H from the acid and it became water, and we have acetate. So in the beginning, how many moles of the acid we have? So we have 0.15 times 40 divided by 1000. So this is the number of the acetic acid that we have in the beginning. Of course, you don't divide by the total volume because you need the moles of the acetic acid only in the beginning. Because after we add the base, it's the end. We need the moles in the beginning before we add the base. So in the beginning, we have 0.006 moles, which is, again, 40 divided by 1000, which is the volume, times the concentration of the acetic acid. And how many moles of OH we added? Right here we wrote it, 0.0058. And of course here, we don't have anything. So what you're gonna do, you're gonna look which one you have more. Of course, you have more of the acetic acid. So you're gonna do minus the fewer number of moles, of course. So you're not gonna get a minus 0.058. Here also the same thing, because it's all gonna react. The coefficients are all 1 here, and water doesn't matter. And the acetate, it's a base, remember? And they are going to react to give us acetate, so it's going to be plus 0.058. So here we have, at the end, we have 0.00023 zeros, okay? Here we have 0, here doesn't matter. That's not x, it just doesn't matter. And here we have 0 plus this number, so 0.00058. Now, in the equation, you need the concentrations, but even if you just divided the moles, because the volume is gonna cancel anyway, but it's just better to find the concentration of the acid and its salt. It's just safer. And your professor or teacher probably wants you to do the concentration, because in the equation you just need the concentration. So now, after you find the number of moles at the end, you're going to divide by the total volume. So we had 40 and we added 29, so we get 69. That's a good number. So the moles divided by 0.069. Here also. And you're gonna get the concentration is gonna be in the salt, it's gonna be 0.084, and here it's gonna be 0.0028. Excuse me, I'm gonna remove this because I'm out of space, but it's better to write this all down. Okay, so the equation is pH equals pKa. Let's just do this. It's just better. The pKa is minus log the Ka. So minus log 1.8 times 10 to the minus 5. So it's 4.74 plus log the salt divided by the acid. So 0.084 divided by 0.0029. If you do this calculations, you're gonna get that your pH is 6.2. Okay, so this is the first part. Okay. Second part, after adding 30 milliliters of base. So let's do the calculations quicker this time because we get it. So we added 0.03 liters of the base and we multiply it by the concentration. So it's 0.003 of the base that we have. Of course, to get the moles of the hydroxide, we just multiply it by 2 like we did before. So we added 0.006 of the base, of the OH minus, sorry. So our equation, same equation, I don't know why I removed it. Same one. OH minus, water, and just the salt. So here we had 0.006. Here also we added 0.006. And of course we do just as before, minus 0.006. Here also the same thing. So we're gonna get 0 from here, 0 from here. So many students actually have this mistake that they wrote that the pH is 7, but as we said before, they react to give us the water and the acetate, which is basic. So here you had 0, but you added 0.006. And here you have 0.006 moles. And to find the concentration, you divide it by the total volume, which is 70. So 0.07. And the concentration of the acetate that you have, 0.006 divided by 0.07, it's 0.085. So what are we going to do with it? We can't use the equation that we used before because we have 0 molars of our acid. So let's remember that the concentration of AC minus is 0.085. Okay. So the acetate is going to react with water by a reaction called hydrolysis. So it's gonna, let's just write it down. CH3COOH minus, it's a basic salt. It's gonna react with water to give us COOH plus OH minus. What matters to us, of course, is a strong, let's say strong base, the OH minus. So here we had 0.0, of course, by equilibrium, this is equilibrium, so you deal with concentrations. 0.85, here we have 0, 0, minus X, 0.085, minus X at the end, and here we have XX. Okay, but now we have the basics, the basic salt, so we can't use the Ka, we're going to use the Kb. And the equation is Kb equals Kw, which is the water, like the Kw is for the water. So it's 10 to the negative 14 divided by our Ka. Okay, this is our Kb. It's a very small number. It's 5.55 times 10 to the negative, I think, 10. Yes. Okay. So Kb equals x squared. Remember, because Kb is very small, we can neglect the minus x here as well. So divided by 0.085. I'm not going to do it again, but if you solve for x, which is the concentration of OH, remember? So x is going to be, so if you multiply 0.085 times the Kb, you're going to get this very small number. And to find the POH, you're going to do the minus log of this number. And you're going to get 5. This is the POH. And to find the pH, you're going to do 14 minus this number. And your answer is going to be 8.84. This is your pH. Okay. So this is part 3 of the question. Let's do the last part. The last part is considered to be the simple question, because obviously in the third part we add the same number of moles of the base, same as the acid. So if we add 31, we're gonna be adding more base. So if we first calculate how many moles of the base we added. So it's 31 divided by 1000, which is the volume in liters, and we multiply it by 0.1. So this is the moles of the base. So it's going to give us 0.0031 moles of the base. And of course, as we said twice before, that the moles of the hydroxide is going to be times 2. So the moles of the hydroxide is going to be 0.0062. Remember that. Now we type the equation of the acid and the base. Acid, we had 0.006 moles. We added hydroxide. How much we added? 0.0062, which is more. And of course we get water and the acetate. Okay, 0, 0. So of course, because we added more, we always subtract the smaller number. So in this case, the acid, we're going to get 0, and here minus 0.0062. Sorry, 0.006. We're going to get 0.0 0.0002, and then we're gonna get, it's not 0, it just doesn't matter, and of course we're gonna add the basic salt, we're gonna add to it 0.006, just the same number of moles that reacted. Okay, as you can see in this case, when you add more moles of hydroxide than your acid, you're going to be left with a strong base, which is OH minus, and another base, but it's very weak. So if you have OH minus, and if you have the basic salt, you just neglect the basic salt and just look at your strong base, which is OH minus. Same with acids and salts. If you have a strong acid and if you have an acidic salt, which is weak, you just look at the strong acid. So we have 0.0002 moles of OH minus. We find the concentration. So the concentration is the number of moles divided by the volume, the total volume, which is 71. It's the concentration is 0.00828 molars. Okay, so this is the concentration of OH minus. We find the POH, which is the minus log of this. So minus log OH minus is the POH, which gives me 2.55. I need the pH, so it's going to be 14 minus this. So pH is going to be 14 minus 2.55. It's going to give me 11.5 or 11.45. Just be sure. Yes. Okay. So this is it. This is how you do it. Just want to say that I offer free organic chemistry help and general chemistry help via Skype. You can, it's 100% free. So if you have any questions or you need any help, you can add me on Skype. It's in the description. And I'm very glad to help. Good luck.